I'm now ready to build my application. I can click on this Make button in order to build the application. It takes a few seconds to compile all the code, but as you can see, it compiles with 0 errors and 0 warnings. I'm now ready to download and debug the application by clicking this green arrow. It takes a second or two for it to download into the board, but once it does, you can see that there are several windows that pop up. The first one that pops up is this disassembly window. Within the disassembly, you can see the C source code statements as well as the disassembly of the code that was generated by the compiler. One thing to note is that there is a green arrow here. When I click in between the source window and the disassembly window, you'll notice that the green arrow changes position. What this means is that if I press the single step, it's going to single step at this point at the disassembly level. If I click over in the source code window and single step, it will single step at the source level. You can change this on the fly so that you can single step through individual parts of the disassembly to see how the code is reacting. Additionally, I can view the registers window by clicking View and then going to Register. You can see that the registers window is occupying a little bit more of my screen real estate, so what I can do is click and drag this register window into my disassembly window in order to dock it, and I can quickly flip back and forth between the tabs. I'm going to start the code running by clicking the Go button, but before I do, I wanted to show you some of the other buttons that are available. You have a reset, and when the code is actually executing, you can break execution. You can step over a function call, step into a function call, step out of a function call, go to the next statement of your source code, run to cursor, and then there's also the Go button. Finally, there's the stop debugging. But for right now, I'm going to press the Go button, and that you can see that the green LED starts blinking while the blue LED remains solid. My break button is now active, so I'm going to click it to stop execution, and I can see where I am in source as well as in disassembly. Additionally, with the iJet debugger, I have the ability to do power logging. If I click on power log, I can see how much power is being provided by the iJet debugger to this particular board. Additionally, I can view this information graphically by going to the timeline window. You can see that as the green LED turns on, the amount of power that's being provided by the iJet debugger goes up, and as it turns off, the amount of power goes down. Similarly, if I double click on any one of the spikes, it will take me to exactly the point in source code where this was measured. For this particular example application, we're in a tight delay loop, so most of the samples will actually be within this delay loop. This helps you when you are looking for ways to shave the power profile of your application so that you can see where the power spikes are occurring and where it is inside of source code. This helps you to understand where you need to focus your power optimization efforts. All of this functionality is given to you by the Embedded Workbench for ARM and the iJet debugger. Thanks for watching this video, and I hope you found it useful.